So in lessons 6, 7, and 610, we're going to be learning to use the quadratic formula to not only find solutions to quadratic equations, but also to determine the nature of those solutions. So our targets in this are to be able to solve quadratic equations, use them to solve problems that relate to the real world, use the discriminant, which is a part of the quadratic equation, to determine the nature of the solutions, and then use the discriminant to determine the number of x-intercepts on the graph of that parabola. So before we left class today, we were talking about the fact that the quadratic formula is a way to solve an equation in the form y equals ax squared plus bx plus c. Now, a cannot equal 0, because if it did, you wouldn't have an x squared, and therefore it wouldn't be quadratic. And the equation, quadratic formula, says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we're going to be using that quadratic formula a ton to help us solve these quadratic equations. Now, it's going to be crucial that before you use the quadratic formula, you always make sure that you get it set equal to 0. So you want it to be 0 equals ax squared plus bx plus c. And once again, a cannot equal 0. Now, we said we're going to use the discriminant, which is a part of the quadratic formula, to help us determine the nature of the roots. This b squared minus 4ac is called the discriminant. And because in the quadratic formula it's going to be square rooted, then you're going to need to ask yourself about what numbers, or what will the answers be when you square root different kinds of numbers. And we were just talking about this in class today. When you square root a positive number, you can get two answers, both a positive and a negative answer. So when b squared minus 4ac is positive, we would say that there are two real answers, two places where that parabola intersects the x-axis. On the other hand, when you take the square root of the number 0, 0 only has one square root, and that's 0. So, when the discriminant is equal to 0, there's one real solution. Finally, if you were asked to determine the square root of a negative number, you could not do it using the real number system. Now, after Christmas, we're going to learn about how we use what are called complex numbers to describe those solutions. But there are no real square roots of a negative number. So that means then that when the discriminant is less than 0 or negative, you'll find there are 0 real solutions. Later, we'll learn to describe them using complex numbers. So this is what the discriminant theorem tells us. It basically tells us those things that we just identified. You'll have two real solutions if b squared minus 4ac is positive. You'll have one real solution if b squared minus 4ac is 0. And you'll have no real solutions. We'll learn these are called complex conjugates. But you'll have no real solutions when the b squared minus 4ac is negative, because you can't take the square root of a negative number. Now, anytime the directions say to you, determine the nature of the solutions, that's all that they're asking you to do is identify how many solutions there are and what type they are. And that's going to be based upon what this discriminant theorem tells us. When you find those solutions, another name for finding the solutions when ax squared plus bx plus c equals 0, that's also called finding the root of a quadratic equation.